All right, let's dive right in. Today, we're talking about one of the most exciting shifts happening in AI right now. It's this move from an AI that just knows a bunch of stuff to an AI that can actually do stuff. We're talking about Agentic AI.
We're all pretty used to chatbots that can answer questions. But I want you to think about this for a second. What if an AI could do more? What if it could actually complete tasks for you out in the real world? What if it could move beyond just talking and start acting?
That question really gets to the heart of the difference we're exploring. On one side, you've got your standard large language model, an LLM. The best way to think about it is as a brilliant brain in a jar. It's incredibly smart, but it's totally disconnected from what's happening right now. But on the other side, you have an agentic LLM. That's a brain with hands. It can get real-time info, and it can actually take action in the world.
So, to really get why this leap is such a big deal, we first have to talk about the fundamental problem with that brain in a jar. It all comes down to something called the knowledge cutoff. Basically, a normal LLM only knows about the world up to the exact moment its training data ended. So, if a model was trained on data that stopped a year ago, it has absolutely no clue what happened yesterday. Its entire worldview is just frozen in the past. So, you're probably thinking, well, why not just update it? It's not that simple, it turns out. First, retraining these gigantic models is super risky. You can actually make them worse at things they used to be good at. Okay, so why not just stuff new info into the prompt? Well, the model's short-term memory, its context window, is limited. And if you throw too much junk in there, you get this needle in a haystack problem, where the AI gets confused. Oh, and it's expensive. You pay for every single token you feed it.
So, if you can't just keep cramming more into the brain, what do? Well, the first really clever solution was to give the brain a library it could check things out from. This technique is called retrieval augmented generation, or RAG for short. So what is RAG? Basically, it's a system that lets an LLM look things up in an external, up-to-date source of information, like your company's private database or even the live internet, before it gives you an answer. It can check its facts on the fly. And how it works is actually pretty straightforward. It's a three-step dance. First, when you ask a question, the system retrieves the most relevant information it can find from its knowledge base. Second, it augments your original question by stuffing that new info right into the prompt. And finally, it asks the LLM to generate an answer, but now it's armed with fresh, relevant context. But here's the kicker. The performance of this entire system really hinges on that very first step. If you can't find the right information to begin with, the rest of the process doesn't matter. It's classic garbage in, garbage out. And this isn't just a guessing game, right? To make sure that retrieval step is working, developers measure everything. They're asking questions like, are the best results showing up right at the top of the list? How fast did we find the very first good answer? And out of all the stuff we grabbed, how much of it was actually useful? Okay, so RAG gives the LLM a library. That's a huge step forward. But what about giving it hands? That's the next massive evolution, and it's called tool calling. This is where we stop just knowing things and start doing things. The official definition sounds a little academic, but it allows the AI to access and act upon external resources to get things done. The key phrase there is acting upon. It's not just reading anymore, it's interacting. But honestly, the best and simplest way to think about it is just this. We're giving the LLM superpowers. The power to use other pieces of software, to call APIs, to interact with the digital world just like you or I would. So how does it pull this off? It's another pretty simple three-step process. First, the LLM looks at what you asked for and predicts which tool it needs, say a weather app, and what info to give it, like your city. Second, the system actually executes that tool. And finally, the LLM gets the result back from the tool, like 72 degrees and sunny, and uses that to generate a normal, friendly answer for you. And this is exactly how modern AI assistants work. When you ask your phone to find a teddy bear shop or tell you the weather, it's not remembering the answer from its training. No way. It's using a tool, like a map or a weather service, to get you live, accurate info right in that moment. Okay, so let's put it all together. We've given the AI a library with RAG, and we've given it hands with tool calling. So what happens when you combine those abilities with a reasoning loop? Well, that's when you get the final, truly agentic leap, an AI that can start to think for itself. So an AI agent at its core is a system that can go after complex, multi-step goals all by itself. It uses everything we've talked about, its knowledge, its tools, and adds a reasoning process to figure out what it needs to do next without you holding its hand. The secret sauce that makes this work is a framework called React. And it's as simple as it sounds. The AI takes a moment to reason, and then it takes an action. And it just keeps doing that. Let's walk through a quick, kind of silly example. Imagine you tell an AI agent, "My teddy bear is cold." The very first thing the agent does is observe. It looks at your statement and understands the core problem. The bear's temperature is too low. Based on that observation, it makes a plan. The first logical step it decides is to figure out what the temperature of the room actually is. And then it takes an action. It calls a tool, something like get current room temperature. And that tool reports back that it's 65 degrees. And this is the magic right here. It doesn't stop. It repeats the loop. It observes, okay, 65 degrees is a bit chilly. It plans, I need to raise the temperature. Then it acts, maybe calling another tool to turn up the thermostat. This cycle of observe, plan, act just keeps going and going until the AI determines the goal is complete.
Now, this is all incredibly powerful stuff, but as you can probably imagine, giving an AI this much autonomy, well, it also opens up a whole new can of worms when it comes to problems and potential risks. I mean, think about it. When an AI can actually do things in the real world, the stakes get way, way higher. Someone could try to trick an agent into sending them private data. It could be told to do something harmful, like delete important files. And because these reasoning loops can get really complex, there's always the risk that an agent could just get stuck or go off the rails in some totally unpredictable way.
So here we are. We've journeyed from a simple brain in a jar to a system that can know, do, and reason about its world. It has knowledge, it has hands, and it has a thought process. The only real question left is what are we going to ask it to do next?